What if I told you that the tallest mountain and the deepest ocean hole on Earth are connected by the same slow moving forces under our feet? Hey everyone, I'm Ben. Welcome back to English Story Mode, the podcast where we learn English through the most amazing stories our planet has to offer. Today, we're going on an incredible journey that will blow your mind. We're talking about how mountains grow, how continents move, and how Earth creates the most extreme places imaginable. Trust me, by the end of this episode, you'll never look at mountains the same way again. Ready? Let's dive in. All right, let's start with something that sounds completely crazy. Picture this. About 200 million years ago, all the continents on Earth were stuck together in one giant supercontinent. Scientists call it Pangaea, which means all lands in Greek. Can you imagine that? Africa, South America, North America, Europe, Asia, all smushed together like puzzle pieces. Now, here's where it gets interesting. In the early 1900s, a German scientist named Alfred Wegener looked at maps and noticed something amazing. The coastlines of different continents fit together perfectly. Like, if you pushed South America and Africa together, they match up like pieces of a jigsaw puzzle. But wait, there's more. Wegener found the same types of fossils, ancient plant and animal remains, on opposite sides of the ocean. How could the same ancient animals live in both Africa and South America if there was a huge ocean between them? They couldn't swim thousands of miles. And get this, he found similar rock formations too. It was like finding the same fingerprint on different continents. Wegener's big idea was called continental drift. He said the continents were slowly moving apart over millions of years. But here's the thing, nobody believed him at first. They laughed at his idea because he couldn't explain how the continents moved. Poor guy was ahead of his time. It's like when I tell my friends I can predict the weather by looking at clouds. They think I'm crazy until I'm actually right. But seriously, Wegener was onto something huge, and it took decades for scientists to figure out he was correct. Fast forward to the 1960s, and scientists finally figured out how Wegener was right. It's all about plate tectonics. Think of Earth's outer layer, the crust, like a cracked eggshell. It's broken into huge pieces called tectonic plates. These plates are constantly moving, but super slowly, about as fast as your fingernails grow. I know, that doesn't sound very fast, but over millions of years, it adds up to thousands of miles. These plates float on hot, melted rock deep inside the Earth. It's like ice floating on water, except the water is molten rock that's over 1,000 degrees Celsius. Crazy, right? Now, what happens when these massive plates crash into each other? Well, imagine you're pushing two pieces of paper together from opposite sides. The paper has to go somewhere, right? It buckles up. That's exactly what happens when tectonic plates collide. The land gets pushed up and forms mountains. And the most spectacular example of this is the Himalayas. About 50 million years ago, India was actually a separate island moving north. Can you believe that? India was cruising across the ocean like a giant ship. Then India crashed into Asia and boom, the Himalayas were born. This collision is still happening today, which means the Himalayas are still growing about 4 millimeters every year. That's like, well, about as fast as your fingernails grow. And sitting right in the middle of this mountain building action is Mount Everest, the tallest mountain on Earth at 8,849 meters. That's almost 30,000 feet. I tried climbing a hill once and thought I was dying. Imagine doing that at 29,000 feet where there's barely any oxygen. For decades, people said it was impossible to climb Everest. The air is so thin up there that you can barely breathe. It's freezing cold and the weather changes in minutes from calm to deadly storms. Many brave climbers tried and failed. Some never came back home. It seemed like Everest would never be conquered. But on May 29, 1953, two incredible men made history. Edmund Hillary from New Zealand and Tenzing Norgay, a Sherpa from Nepal, became the first people to reach the top of Mount Everest. What I love about this story is that it shows the power of teamwork. Hillary was an experienced climber and a beekeeper. Yeah, he worked with bees. Tenzing was a local Sherpa who knew the mountains like the back of his hand. Sherpas are amazing people who live in the Himalayas and are natural mountain climbers. Together, they spent months preparing, carrying heavy equipment, setting up camps at different heights to get used to the thin air. When they finally reached the summit, they hugged, took photos, and left some chocolate and biscuits as an offering. How cool is that? But here's something that absolutely blows my mind. Plate tectonics doesn't just push things up, it also pulls them down. When one tectonic plate slides under another plate, scientists call this subduction, and this process creates the opposite extreme for mountains, incredibly deep trenches in the ocean floor. The most famous of these is the Mariana Trench in the western Pacific Ocean. Get ready for this. It's over 11 kilometers deep. That's about 36,000 feet down into the earth. If you took Mount Everest and dropped it into the Mariana Trench, the mountaintop would still be underwater by more than a mile. Can you imagine that? The Mariana Trench was formed when the heavy Pacific Plate started sliding under the lighter Mariana Plate. Picture this. The Pacific Plate is so dense and heavy that gravity pulls it down into the Earth's hot interior. As it bends downward, it creates this massive V-shaped scar in the seafloor. The deepest part is called Challenger Deep, and it's like Earth's hidden basement. The water pressure down there is over 1,000 times stronger than at sea level. If you were somehow magically transported down there, you'd be crushed instantly. It's so extreme that humans have only visited the bottom a few times in special submarines built like tanks. Think about this for a second. Thousands of people have climbed Mount Everest, but only about 4 people have ever been to the bottom of the Mariana Trench. We know more about the surface of Mars than we do about the deepest parts of our own oceans. That's because space is actually easier to explore than the deep ocean. In space, you just need to protect yourself from no air and radiation. But in the deep ocean, you have to deal with crushing water pressure that would squish a submarine like a soda can. Every square inch down there has the weight of a small car pressing on it. Absolutely incredible. So let's wrap this up because this story is just amazing. We started with Alfred Wegener's crazy idea that continents could move, and he was totally right. Continental drift led us to understand plate tectonics, which explains how Earth creates its most extreme places. When plates crash together, they push up massive mountain ranges like the Himalayas, giving us giants like Mount Everest that brave people like Hillary and Tenzing could conquer. When plates pull apart and slide under each other, they create mind-blowing deep trenches like the Mariana Trench, places so extreme that they're harder to visit than outer space. All of this is happening right under our feet, every single day. The ground you're standing on right now is slowly moving. Isn't that just the coolest thing ever? And you know what? You just learned all of this in English. That's the power of English story mode. When you learn through fascinating stories like this, English becomes fun and memorable. You're not just memorizing vocabulary, you're discovering incredible facts about our amazing planet. Every episode is a step forward in your English journey, and you've got this. I believe in you. If you enjoyed this episode, hit that subscribe button so you never miss a story. Give us a like and drop a comment below. I want to hear from you. Tell me, what's the hardest part of learning English for you? Are you struggling with pronunciation, grammar, or maybe building confidence to speak? And what topic should we explore next? Maybe the formation of volcanoes, the story of dinosaurs, or how the internet was invented. There are 10 questions in the description box below to test what you learned today. Give them a try and see how much you remember. Until next time, keep exploring, keep learning, and keep being awesome. But wait, we're not done with this incredible story yet. There's another dramatic way that plate tectonics affects our daily lives: earthquakes. When I was explaining how plates move slowly like fingernails growing, you might have thought, well, if they move so slowly, why don't we feel anything? Here's the thing. Most of the time, plates get stuck against each other. Imagine trying to slide 2 pieces of sandpaper past each other. They don't slide smoothly, right? They catch and stick. The same thing happens with tectonic plates. For years, even decades, the plates push against each other but stay stuck. All that energy builds up and builds up, like stretching a rubber band tighter and tighter. Then suddenly, snap. They break free and lurch forward. That sudden movement is what we call an earthquake. And if earthquakes aren't dramatic enough for you, let's talk about volcanoes. These are basically Earth's pressure release valves. Remember that hot molten rock I mentioned earlier, the stuff that the tectonic plates float on? Well, sometimes that melted rock, called magma, finds cracks in the Earth's crust and pushes its way up to the surface. When it erupts, we call it lava. Most volcanoes happen right at the edges of tectonic plates, where the crust is weakest. It's like squeezing a tube of toothpaste. The toothpaste comes out where there's an opening. The Pacific Ring of Fire is a perfect example. It's a huge circle around the Pacific Ocean, where tons of volcanoes and earthquakes happen because that's where several major tectonic plates meet. Countries like Japan, Indonesia, Chile, and even parts of the western United States sit right on this ring. It's both beautiful and terrifying at the same time. Speaking of incredible mountain ranges, the Himalayas aren't the only ones with amazing stories. Let's take a quick trip around the world to see how plate tectonics has shaped other famous mountain chains. The Rocky Mountains in North America, they were formed when the oceanic Farallon plate slid under the North American plate about 80 million years ago. That's right, there used to be an entire ocean plate that just disappeared under North America. The Alps in Europe have an equally wild story. They were created when Africa started pushing into Europe, crumpling up the land between them like an accordion. And here's something mind-blowing. The Alps are still growing today, just like the Himalayas. The Andes Mountains in South America are the result of the Nazca Plate diving under the South American plate. This process is so active that the Andes have some of the world's most dangerous volcanoes, and earthquakes happen there regularly. It's like the Earth is constantly reshaping itself. Understanding plate tectonics isn't just cool science, it actually helps save lives. When scientists figured out how earthquakes work, they started building earthquake warning systems. In Japan, they have sensors that can detect the first tiny movements of an earthquake and send warnings to people's phones before the big shaking starts. It only gives you seconds or maybe a minute, but that's enough time to take cover or stop a train. Scientists also use this knowledge to predict where future earthquakes and volcanic eruptions are most likely to happen, so cities can prepare better buildings and emergency plans. And here's something amazing. By studying how continents moved in the past, geologists can actually predict where they'll be millions of years from now. They know that in about 250 million years, all the continents will probably smash together again to form a new supercontinent. Of course, humans probably won't be around to see it, but it's incredible that we can predict something that far in the future just by understanding how rocks move under our feet. That is all for today's episode, everyone. We will see you next time on the English Story Mode channel. Bye-bye.